Hi, welcome to Can These Two Businesses Both Be Telling the Truth? In this video, we're going to pose a statistical question about a hypothetical scenario. This scenario involves two competing stores, each of which seems to claim to be cheaper than its competitor. This will give an example of a situation in which people can use statistics to mislead. Okay, let's get started. Let's imagine that your town has two competing grocery stores, Store A and Store B. There's a convenient grocery delivery app that lets you tell it all the groceries you want to buy, and it gives you the price of your total order at each store so you can choose which store to order your groceries from. Store A claims that customers who chose Store A in the app saved, on average, more than 10% compared to what they would have spent if they had chosen Store B. But Store B claims that customers who chose Store B in the app saved, on average, more than 10% compared to what they would have spent if they had chosen Store A. Is it possible for both of these stores to be telling the truth? Let's see if we can construct a situation in which both of these stores' statements are truthful. For simplicity, let's assume that the products and service provided by both stores are identical and that people choose a store based entirely on price. First, we'll hypothesize that the two stores differ in how they price individual products. So, Store A may have lower prices on milk, pasta, and cannellini beans, while Store B may have lower prices on oatmeal, bananas, and cat food. For simplicity, let's guess that if we looked at the fractional price difference between products from the two stores and averaged overall products, that neither store would be much cheaper than the other one. Let's imagine a large number of customers try the app. For each customer, we'll construct the percentage difference, which we'll call D, in the price of their grocery basket between the two stores. We'll call the price of their grocery basket at Store A, PA, and the price at Store B, PB. So the percentage difference in their grocery basket is D, which equals 100 times PA minus PB over PA. And here the 100 is just to convert from a fraction to a percent. So, for example, with this definition, a customer would have D equals 5 if Store B was 5% cheaper than Store A, and would have D equals minus 10 if Store B was 10% more expensive than Store A for their grocery basket. Let's say 10,000 customers try the app and see what the distribution of the values of D looks like. Here we plot in each bin the number of customers that had D fall in that bin. So for example, of the 10,000 customers, approximately 250 had a value of D between 0 and 1. And about 120 had values of D between 20 and 21. In making this plot, we have guessed that the distribution for D would be shaped like a Gaussian or normal distribution. Here, for each customer, we're looking at the cost of their basket of groceries and comparing this at Store A and Store B. The cost at each store is the sum of the cost of items in the customer's grocery basket. Often, if you're looking at the distribution of some quantity that is itself the sum of many smaller independent quantities, that distribution will look approximately Gaussian. So while the Gaussian shape won't be exactly right, it's a reasonable guess for approximately what the distribution for D might look like. For more info, you can check out the video Why the Gaussian or Normal Distribution is Important. Here, D is greater than 0 when store A is more expensive, and D is less than 0 when store B is more expensive. The distribution is roughly symmetric, so there is no real advantage on average of choosing either store A or store B over the other. Now, we just saw that neither store is, on average, much cheaper than the other. So can both of them, or even either of them, be telling the truth? Let's look at those claims again. Store A claims that customers who chose store A in the app saved, on average, more than 10% compared to what they would have spent if they had chosen store B. Note that they do not say that customers overall would save 10% at store A compared to what they would spend at store B. They only say that the customers who chose store A saved compared to store B. Now, we're assuming that customers choose store A or store B exclusively based on the price of their basket of groceries. In this case, the customers who choose store A are those for which store A was cheaper. These are the customers who had D less than 0. Let's look at just those customers. Here is the distribution of D for those customers, approximately half of the original sample, for which store A is cheaper. Store A is claiming that these customers, on average, save more than 10% compared to what they would spend at store B. That is the same as saying that for these customers, D, on average, is less than -10. This is quite believable from the plot, as the maximum value of D is 0, and a significant number of customers had D less than -20. In other words, a savings of greater than 20%. Meanwhile, store B claims that customers who chose store B in the app saved more than 10% compared to what they would have spent if they had chosen store A. Customers who chose store B are those customers for which store B is cheaper, so those customers for which D is greater than 0. Here is the distribution of D for the customers that store B is talking about, so the customers for which D is greater than 0. Store B is claiming that these customers, on average, save more than 10% compared to what they would have spent at store A. So store B is claiming that for these customers, on average, D is greater than 10. Again, this is quite believable from the plot. So, can both of these stores be telling the truth? Yep. In fact, neither store is claiming that it is cheaper on average than the other. It just sounds like they are. Instead, they are saying that in the cases when they are cheaper than the other store, they are cheaper by, on average, more than 10%. They aren't saying how much more expensive they are in the cases that they are more expensive. In fact, we could imagine a scenario in which store A is, on average, cheaper than store B. Perhaps only 3% of customers would find that their grocery baskets are cheaper at store B. But store B could still claim that customers who chose store B in the app saved more than some amount compared to what they would have spent at store A. It's just that, based on price, there would be very few customers who would choose store B. By considering only the customers who choose their store, both store A and store B skew the statistics to make their own business appear more favorable. They may be hoping that customers will just conclude that they are the cheaper store, not check prices, and come in to buy groceries. One thing we can gather from their claims, however, is that an individual customer may find it advantageous to compare prices before shopping at either business. Okay, so let's summarize. Here we've seen a hypothetical scenario in which two businesses may initially both appear to be claiming to be less expensive than the other. While their claims are technically true, they are misleading. It's important to keep in mind that conclusions made about part of a population, here either store A's customers or store B's customers, do not necessarily hold for the whole population, here all customers.